hi everyone. Welcome to the spring quarter inaugural HAI Research Seminar Series. I'm Deep. I'm the Director of Research at HAI. And before we get started, and I introduce you to Jack Clark, I just want to lay out a couple of house rules. So first, Jack's going to present on the AI Index report for about 30 minutes, and then we'll open it up to Q&A. If you have questions for Jack, please submit your questions via Slido. You can find that Slido application by pointing your mobile device to that QR code up there, or you can just go to the HAI website and click join the conversation under the events page. I will be monitoring those questions throughout, and at the end I will sort of feed those to Jack, and it will be somewhat like a conversation about the materials he presents today. Okay, so that's sort of it for house rules. Oh, one last thing I should say is that the chat will be disabled. So the only way to submit questions is through the Slido application. Okay, so moving on, it's my pleasure to introduce you to Jack Clark. He is the co-chair of the AI Index Steering Committee, an expert member of the Global Partnership on Artificial Intelligence, or GPI as we call it. He's also a co-chair of the OECD's Working Group on Classifying and Defining AI Systems. He's also a non-resident research fellow at the Center for Security and Emerging Technology, or CSET, based out of Georgetown. And many of you probably also know him from his work with the Import AI newsletter, which is about AI and AI policy, read by more than 25,000 people around the world. And he's formerly the policy director at OpenAI. So Jack, I got kind of tired listing all your numerous qualifications. And Jack today is going to talk about the AI Index report, which is an independent initiative out of HAI, which sort of seeks to ground the conversation about AI, which is a rapidly evolving field, in data, so that policymakers, academics, and journalists can make sort of evidence-based decisions about the state of AI. So with that, I'm happy to hand it over to you, Jack, and take it away, and I'll see you at the end.
Awesome. Thanks very much, Deep. Let me just share my screen. So welcome, everyone. Thanks very much for coming along to this presentation. And I'm going to spend about 30 or 35 minutes talking about the AI Index, talking about what we've learned this year, and also highlighting some of the things we're trying to do in the future. And I love questions. I'd love for this to become more of a conversation. So please don't hold back. Happy to have a lot of discussion. So just a couple of basics. What is the AI Index? Well, as Deep mentioned, it's a sort of independent project, part of the 100-year study on AI at Stanford University. And we're in our 4th report this year. We've been running for about 4.5 years. And why I'm giving this presentation today and why we've been doing a lot more activity around the report this year is the report has really grown and matured during that time. So it started out as a relatively small project. And today, as you can see here, we are very fortunate to have a very sort of well-appointed and engaged steering committee, which I'm lucky to co-chair. And we get to work with some really fantastic staff as well, including Daniel Zhang, who led a lot of report production and research this year, and Saurabh Mishra. Now, the steering committee is constantly sort of finding ways to add more people and expand itself so that we can take a divide and conquer approach to the increasingly ambitious and tricky task of trying to assess and measure AI. So if you have any interests or ambitions in that direction, please don't hesitate to reach out and contact me. We're also really fortunate to work with just a huge amount of collaborators. The index report contains a lot of information. Lots of that information comes to us through organizations that we partner with or spend time talking to through the year. And all of the intelligent bits in the report probably come from them, and the mistakes probably come from us, to just be extremely English about that. But the reason why we work with such a large set of people is because of the philosophical challenge inherent to trying to classify and sort of define AI systems. And I've actually come up with a visual metaphor for this philosophical challenge that I thought I'd show everyone here, which is this. Here we have a picture of a bunch of distinguished scientists and organizations all touching different parts of an elephant. And different scientists who are touching different parts of this elephant have different opinions about what it is. Someone might think that the elephant is the elephant's trunk with their eyes closed is a rope. Someone might think that the tusk is a spear. Someone might think that their ears are a fan. You get the picture. Now, I'm using this to make the point that measuring and assessing stuff is fraught with these challenges of are we able to zoom out and tell you the big picture, or are we going to get trapped into some subjective individual measurement? And our hope with the index and what we design it to do is to give you the picture of the whole elephant, which in this analogy is artificial intelligence as a field. Just a final bit of context about the index, and then I'm going to get into the meat of presentation. But why it exists, along with being a part of the 100-year study on AI, is that it has two kind of basic goals. The first goal is to make the field of AI more legible to experts that want to know about it, whether that be other researchers or policymakers or people who are just interested in AI and want to get a sense of what's been going on in the last year. The other goal is that we want to continually prototype better ways to measure and assess AI, because this in itself is an in development area. And our theory of change is that eventually governments are going to be measuring and assessing a lot of stuff around the AI sector, because they do this with every other part of the economy that matters. So we should assume that they do it here. And the index, by continually prototyping different ways to assess and measure this space, can hopefully contribute to those large government schemes when they arrive. Now, why I do it is, as kind of Deep alluded to in his introduction, I'm very fortunate to spend a lot of time working in AI research and AI policy broadly. And when I was at OpenAI for the last few years, I had this experience of working at an organization that made technologies such as GPT-2 or GPT-3, quite interesting examples of the frontier of some part of the AI research space. And I noted that it's hard to measure these things, it's hard to assess them, and I had a lot of privileged information about those things which other people didn't. And I thought, just subjectively, gosh, I really think that this should be different. I think we need better ways to assess and measure AI broadly, and I think that we need institutions like the index to sort of scale themselves up so that we can provide a better kind of shared conversation around these technologies. So with that, I'm going to give you some takeaways from this year's report, and then we can break for questions. I'm going to structure this in the form of going through some of the investment and technical trends, then discussing aspects of the R&D ecosystem around AI, and then go into some of the challenges we identified. Then I'll discuss some gaps, areas where we lack information today, some of the future opportunities that we're working on at the index, and then just a couple of final thoughts from me, and we can break for Q&A. So what's happening? What's happening specifically in AI investment and sort of technology? Well, a huge thing that we noticed this year is AI is transitioning from applied research field to a technology that is being applied in distinct industries. And what I mean by that, as this graph shows, is we're seeing the amounts of investment that are going into the applications of AI, such as AI for molecular assay or drug discovery or what have you, has substantially increased on prior years. But this trend kind of holds when you look at other applied areas like autonomous vehicles, where we're seeing continued applications of the technology into that vertical domain, money laundering, fashion, games. All of these are indications that AI has matured enough that it's now got some somewhat generic techniques which are being applied in completely different industries from the sort of technology and computing industry where AI probably found some of its first bits of traction. Second, and we're going to spend quite a bit of time on this, there is just an absolutely huge trend in AI that I think explains maybe 50 or 60% of what's happened in the economy around us. And that's just the way that image recognition has got good. And I'm going to be really, really clear with this. What you're seeing here is a graph that shows what's called top one accuracy on ImageNet. That's a measure of, if I show you a picture and I ask you to label it, what percentage of the time is the one label you suggest correct? And we've gone from around 60% correct in 2013 to around 90% today if we use extra training data. There's a big difference in being right 6 out of 10 of the time to 9 out of 10 of the time. And it's one of the reasons why we're seeing AI being applied so broadly, is that being able to see and label the world is such a basic capability. And for it to have got this good drives a lot of downstream deployment. And you can get a really clear sense of this by looking at perhaps a more popular way of measuring ImageNet is what's called top 5 accuracy. And top 5 accuracy is, I give you a picture, you produce 5 labels. If one of those labels is correct, you get a point. And here we've gone from, around 85% correct in 2013 to 97 or 98%. That's interesting. That's commercially interesting. It's not reliable to the point that you'd, plug it into a truly critical system. You'd want 99.9999% or something for that. But it's certainly interesting enough to get you to experiment with applying it broadly in the economy. And there's another trend hidden in here, which is worth us all paying attention to, and that's this green line. So the green line here tells you the scores we're getting on image recognition using extra training data. So why is that interesting? Well, it's interesting because extra training data costs money. It costs money to gather data. It costs money to train image recognition systems on larger amounts of data. And so if companies and researchers are using extra data, it means they're investing more in training these systems, likely because they see some major benefit from doing that. And when I say extra data, I mean a lot of data. I'll give you a very specific example. Facebook pre-trained an image recognition system on billions of pictures from Instagram. This is just a quote I pulled out of a Facebook paper this morning before starting to give this presentation. And I'm highlighting that because if I'm training an image recognition system on 1 billion+ images from my social network, that all costs a huge amount of money. And you do it because it's useful. So we should take these metrics as sort of real indications of the way that AI has become sort of a core part of how companies do certain types of R&D or economic expansion. And just to stress this, a consequence of this improvement in research is we've generally improved our ability to train normal or sort of commodity computer vision systems to the point that it used to cost about $2,000 to train a computer vision system on a public cloud like Amazon or Google or Microsoft. Now it costs $7.50. So to use a sort of a mental calculation I'll sometimes do, it now costs me like 2 beers to train a computer vision model that can classify almost anything if I have the right data. And that's just an amazing capability that humans as a species did not have 5 years ago. This has all happened tremendously quickly. As a part of this, something that we're really interested in measuring at the index is how AI as a sector has diffused from a research community to a much broader set of stakeholders. And we can see the story of this in something we track called YOLO. So YOLO, it's not you only live once. The acronym actually stands for you only look once. And it's a computer vision system applied to streams of images that typically come from security cameras or other things deployed in the world. YOLO is open source software that people will use to categorize images. So it's a very applied instantiation of what we've just talked about with computer vision. But if we look at who makes YOLO and where they are in the world, there's an amazing story here. YOLO is originally developed at the University of Washington in America for YOLO versions 1 through 3. And you see version 2 and 3 on this graph. Then YOLO gets developed by a bunch of independent developers working in both Russia and Taiwan together as a team, which is itself a very interesting geopolitical story and gives us a sense of how international AI has become. And then now one of the more popular packages of this YOLO software is actually developed by a very large and well-funded team at Baidu. So a foreign company investing in an open source package because it lets them do useful stuff with computer vision. So this gives you a sense of just how much larger the AI ecosystem has become over the last few years, and the range of actors in it have changed as well. And finally, I want to come back to this idea of cost again, because I think it's a useful thing for us to be aware of. We aren't getting these advances purely through research innovations. We're getting them through stuff like Facebook training on billions of Instagram images. We're also getting them through the use of computation. So here you see some graphs about the amount of computers used to train cutting-edge computer vision systems in recent years, and you'll see that there's been a trend towards using larger and larger sets of computers to train image recognition systems faster and faster. And so this means that if you're someone like Google now or Amazon, a couple of years ago, it would take you 6 or 7 minutes to train a new computer vision network if you're in the money is no object, large infrastructure world. And now it takes you under a minute. This is kind of wild. We have a 6x decrease in the time it takes to train stuff from the point of view of a research engineer or a researcher there. And it might explain why we see these companies doing so much more stuff with AI. It's got faster, cheaper, and better. And this is a pretty potent combination. Another trend that everyone here is probably familiar with, but is worth just emphasizing, is synthetic media, or as is sometimes colloquially known in the media, deepfakes. So on the right here, you see images that have been synthetically generated via an AI system. These images are not based on real people. They are what the system generates after you've taught it how to generate things that look like real pictures of people. And as you can see, 2014, 2015, we're able to generate images that everyone knows are not real images. It's plainly obvious. But come 2020, or even as early as 2018, we're able to generate images that most people find indistinguishable from reality. And this has, very profound effects in the world, and is one other symptom of how AI is going to start changing things for us. And then on the lower left, what you have here is just a technical metric called threat inception distance, which is one way that we can measure the improvement in these things. So a lower FID score means that you're generating a higher quality of a synthetic output. And as you can see, this trend as well is sort of proceeding quite regularly. And in fact, in recent years, it may have even the trajectory may have steepened slightly. So we may be seeing further improvements at a faster rate than before. So that's technology. I want you to remember that more money is being invested into AI, and some of the core AI technologies, and there we just zoomed in on computer vision, are getting sort of faster, cheaper, and better. They really, really are, and it shows up in a broad set of places. So how does this relate to the larger R&D ecosystem that AI sits within? Well, unsurprisingly, more people are publishing research about AI than ever before, which I think makes sense. If we've just discussed about how valuable and useful AI is becoming, you'd expect to see this. So here we track AI journal publications worldwide, and you can see this quite significant increase. 2020 may be a slightly confounding factor because people were stuck at home for COVID, and maybe that means some people just write more journal papers. We can look at this another way through looking at conference publications, where conferences are, rather than journals, where you tend to see newer papers get published, and they also review papers on a faster timeline than journals. So the fast publishing part of the AI ecosystem has also been speeding up. And I think it's pretty obvious that conferences saw fewer publications happen in 2020. And one of the reasons for this was COVID, because some conferences just didn't happen, rescheduled, or changed certain other details about themselves. However, and we'll return to this, AI isn't a globally distributed technology, nor is it a globally distributed research community. In fact, if you look at this graph, you'll see that AI is kind of dominated by North America, Europe and Central Asia and East Asia and the Pacific. But really what this actually looks like is USA, China, and the European Union countries plus England. And then you have very, very stubborn and poor sort of representation among other parts of the world. And what I mean by stubborn is it's growing very slowly. Some people are trying to carry out interventions here to improve things, but it's worth bearing in mind that AI is not global in the sense of its research base. Related to this, I, as Deep mentioned, spend a lot of time in policy contexts in which I'll learn about competition or competitive issues between the US and China. It's worth knowing that when we look at the metrics now, the US and China look much more like peers than necessarily competitors. And what I mean by that is that China's AI ecosystem has just matured quite substantially, and now it's sort of within the same distribution as the EU and the US in a bunch of different places. It's less about modeling the US and China sort of vying for supremacy against one another. We may not even agree with that frame. It's more noting that China has, after many years of significant investment in AI, very much arrived on the world stage as a leading sort of research hub and true peer of the US, which until recently, you could consider as being an outlying country or region when it came to AI development. However, there are some very interesting differences between the US and between the US and China and between the US and Europe. Notably, when we look at both China and Europe, you see that the vast majority of publications come from academia. Then the second most significant pocket of where publications come from is actually government or government affiliated organizations. Let's look at America. It's a completely different picture. Here, academia, same as the prior graph, leads, but then your most dominant sort of collaborator with academia is the corporate sector rather than the government sector. Let's just flip back and forth quickly to give you a sense of this, but these changes are highly significant. It's a big difference between first, second, and third. And here in second in China, and it's a very similar trend in Europe, is government, and here in second in America is corporate by a wide and non-trivial margin. And so when we think about why the US ecosystem has produced some companies that are commercializing AI really rapidly or deploying it really rapidly, this might be one of the things that indicates why that is. It wouldn't be sort of prudent to cover the exciting things without talking about the challenges, though. So, the first couple of segments of this presentation, I've tried to show you how AI has become a more significant and useful technology in recent years, and also how the research ecosystem for AI is sort of becoming livelier over time, and it's having more representation of different countries, including places like China, though there are some equality issues. We should note, though, that there are some serious challenges that face the kind of AI sector or AI industry, and we're going to try and highlight those now. So one of the first challenges, and I'm sure that everyone here, understands this intuitively, is AI it isn't very diverse. There's no really easy way to sort of state this. It's that when you look at the metrics, AI is dominated by, white people and Asian people, and you have much poorer representation from sort of other demographic groups. There's also gendered elements to this as well, where you tend to see an underrepresentation of women and an overrepresentation of men in various places that you look. Now, this is ultimately going to have, interesting downstream impacts, and many argue that the lack of sort of diversity in the people that do AI research may have knock-on effects on the types of systems that get developed. And we'll go through just sort of one potential example of this now as a way to make this challenge real. So before we get to that example, we should note that it's not all bad news. You know, everyone is more interested in fields like AI ethics. So though we have some of these representational issues, you're seeing researchers tend towards a greater degree of sort of self-interrogation about AI and a greater desire to publish about some of the ethical or societal challenges implied by AI technologies. However, our ability to sort of measure and metricize these ethical issues is actually really quite poor or juvenile today. And what I mean by that is, on this graph, you see a study which looks at the speech recognition systems deployed by major companies, and it looks at how well they perform for Black speakers versus white speakers. And as you can notice from these graphs, they all do pretty well on white speakers, probably ones that speak in a sort of transatlantic received pronunciation manner, like myself, I'd hazard a guess. They do worse on Black speakers, which probably means they do worse on people speaking with accents, diction, or slang terms, which are not as well represented in their data sets or other aspects of data. And when we zoom in further, you see even within this sort of disparity situation, you see further disparities that are gendered, where it can, hear Black men less well than Black women, and it can hear white men less well than white women, but the deltas between white men and white women are much smaller than between Black men and Black women, and the deltas between Black speakers and white speakers are just huge. So we need to remember this because, maybe some of this comes from the diversity or lack thereof in the AI research base, maybe, but our ability to understand the ethical challenges of AI is connected to our ability to measure and assess it. And things like this graph I'm showing here are great, but they're all too rare, which is something I'll cover towards the end of the presentation. And we should all as a community bear in mind that now that AI systems are making money, and now that AI systems have got faster, cheaper, and better and are being deployed, we need to measure who they benefit during deployment and who they don't benefit. And we need to develop a whole new language around assessment and measurement to help us deal with these societal challenges as well. As part of this, more and more of our researchers are heading into industry. This isn't actually this isn't neither a positive nor a negative thing, but it's a trend that shapes the AI ecosystem. So you're seeing a higher proportion of your kind of brilliant new PhDs heading to the private sector, where they will work in a commercial context, which will help them sort of deploy more and more AI technology into the world. But arguably, this is a sign that we should be finding ways to fund our academic research sector more, or do things to retain people, because otherwise you have a generational issue where there are just less people to educate the next generation of AI experts than there were before, at the same time as you have massive increases in demand for studying AI PhDs from people around the world. So this is a trend that's sort of worth noting. And the final point I'll make before I discuss some challenges, future projects, and go into closing thoughts is the fun is just beginning. And what I mean by that is politicians are, politicians and policymakers are much like the super tanker that was recently stuck in the Suez Canal. They are slow to move, but when they move with great significance and weight. And so what we're seeing when we look around the world, and this is the US Congress in particular, but we see the same in Canada and the UK and other places, is a massive and meaningful increase in political interest in AI, which makes sense. AI, as I've said, is raising more money, has become more useful, and the research has become a lot more applied. So yeah, we would expect our elected officials to now be paying attention to it, but the scale at which they're now talking about it feels extremely profound and sort of pronounced relative to prior ones, and should indicate to us that major legislative actions are probably coming, major regulations are probably coming, because you don't have all of this all of this discussion and heat and light without some action eventually in policy. So we should all bear that in mind. Now, as part of doing the index, one of the fun things we get to do, as I've discussed, is we get to identify gaps. We get to identify things that we can't measure or which we're challenging to measure today. So here are some of the meaningful things we found that I think I'll just list for you. And if anyone wants to help or has any of this data, please contact me. But how much does the US federal government spend on AI? We don't know. We know some things. We can tell you about how much money it spends on aspects of its military, although the US government actually produces multiple different numbers here. So you can have multiple numbers from the same agency to tell you about the same thing it's spending money on. So it's still confusing. But what about civil spending? What about how much the government spends on civil projects? There it is also really challenging to get real numbers. And our ability to understand the forces driving the AI ecosystem is linked to this. If we don't know who's spending what, it's hard to know who might be influencing things. And more broadly, it's very challenging to model spending in governments on AI as a whole. Every government has different ways of defining AI. Every government has different accounting schemes. Every government has different bureaucracies. And finding ways to get numbers which let us compare nations in terms of expenditure has been and will continue to be a challenge. And that's an area where we need more coordination. Also, as I've discussed throughout this, we have these big questions about diversity, who are the PhDs, but we should also ask, who are the teachers? Who are the existing teachers and professors, and how diverse are they or not? Because understanding this will help us understand policies that could be put in place to further improve the diversity of your sort of research base. As I've discussed, we need better metrics on things like fairness and bias in AI. Our ability to make a difference on these problems is related to how well we can measure and assess them today. And related to that, we need to do the same for the security implications of AI, which is an area that the index hasn't really touched because there are just frankly no really good obvious ways for how you measure and assess this yet. And that's something that should change. And an open problem is, to tackle these questions of AI ethics, we need to create quantitative metrics about issues that are sort of qualitative and contextual and societal. And this is just, to put it plainly, extremely hard and requires like a lot more people to sort of work on this. And there are good signs here, but we need more. So what are some future opportunities? Well, one thing I'd just like to draw people's attention to before we close the Q&A is this thing that we built at the index this year called the Global AI Vibrancy Tool. And the purpose of this is we take all of the metrics that we have in the index and we use that in a user modifiable tool to let people rank countries or compare countries. So here you can see how we can use this to do sort of per capita ranking of countries according to competitiveness on various metrics. We're interested in doing both absolute ranks and per capita ranks. And this whole area is one where we have been surprised this year by the huge level of interest in the sort of vibrancy tool. And we have been caveating it to governments and others that talk to us about it. But there's clearly demand from people to try and figure out ways to both analyze countries, but also analyze metrics within a single country in a more sort of unified way. So another thing that we do in this vibrancy tool is we let you zoom into an individual country and then look closely at those metrics as well. This is an area of open and continuing work for the index, and we're planning to do some ambitious vibrancy projects this year with other organizations. If you'd like to help us think about this, please get in touch, because it feels like a big opportunity, but it's also a big challenge. So we need more help. And I'll just give you my final thought before we go for Q&A. I think many of the big questions people are asking about AI right now relate to things like, who does AI favor? How does AI affect the economy? Does AI cause unemployment? Is AI genuinely unsafe in some deployments, or is it okay? These are all sort of big, important questions, but we can't manage those questions if we can't measure them. If we can't measure these traits, it means that we're trapped in this world of qualitative discussion. And if you want to get sort of policymakers to move, or you want to coordinate large sets of people, having hard metrics is better. And it's really, really, really difficult, but feels really, really important. Another thing that feels important to note is that the index exists because AI is proceeding unusually quickly. As I discussed in the computer vision section, it is shocking how far the industry has come in 5 or 6 years. I just can't like overemphasize this enough. It's really, really wild that we have computer vision systems that broadly work for certain tasks now and are being used in a massive way in the economy. That's just something that 10 years ago would have seemed like a completely kind of speculative thing, and then in a very short amount of time has become real. So we need to more rapidly measure and assess this because change is happening at a rapid rate. And finally, and this is somewhat personal, but I get to have tons of conversations with interesting people about AI. And in my former role at OpenAI and my current role where I co-founding a new AI research company, I get to have lots of conversations with leveraged, interesting people. And I mostly encounter a lack of information on their side, which is very, very scary to me, because it makes me realize that as AI becomes more influential and more powerful, there will be an incentive for some people to create information that serves their narrative, or information that lets them affect a particular commercial or policy goal. And ultimately, if we want our governments to be able to effectively sort of oversee and manage and lightly direct the evolution of this really important part of the economy, we need them to have better information that's more trustworthy. And so my hope is by doing the index, we can prototype this, but eventually this is going to look like a, society-wide assessments and measurements to help us get all of the benefits of AI and avoid some of the potential challenges. So with that somewhat grandiose, but I hope interesting thought, I'd love to go to Q&A. And if anyone has any comments or constructive criticism, you can reach me on Twitter at JackClarkSF. Thank you very much.
Thank you, Jack. That was really fun. I am so happy to say that this is the kind of the most questions I've seen on Slido for one of these seminars. So I'll do my best here to kind of keep the conversation rolling. And to the audience, I'm very sorry if I don't get to your questions. So maybe to kick us off, you started your talk with this picture of a whole elephant and trying to sort of identify what that thing is by essentially poking and jabbing on it. Throughout that process, and you somewhat spoke to this at the end, what did you find was really the hardest to assess and measure? What's the easiest to assess and measure? And in your opinion, what's most important, and how does that correlate to what's hard or what's easy to measure?
Great question. So what's easy to measure is, it's kind of intuitive. It is the technical metrics that the researchers are optimizing for, like your top one accuracy on ImageNet, or your loss on an NLP model like GPT-3, because these are technical metrics that are well understood and in the research community been worked on for years. What's hard to measure, as I discussed, is any of these qualitative things, like fairness and bias is just a really great example where we know that evaluating bias is a big contextual multi-headed problem, and yet we're trying to ground it out into single metrics here, which is almost a paradox, but is one that needs to be worked on. So that's really, really hard. What do I think is important? I think these ethical metrics may be the most important, because from where I'm sitting, the discussion around ethics and deployment would be improved by more evidence, and we can generate more evidence with more metrics. A speculative thing that I'd like to exist, which I don't think people are working on yet, is how do we measure the effects of AI on people that use AI? So if I'm, say, a journalist who started to co-write with a natural language processing engine, how does that change me over a few months? I'm sure that there are like metrics and studies there which will happen in the future, and I think that will become an important thing as well.
So let me piggyback back off that sort of last part. And this is a question directly from the audience. It's actually one person who asked two questions that I'm going to try to kind of tie together. So the first one is, you mentioned the impact of extra training data on ImageNet. And the first question here is like, is such data sometimes used to address data bias in order to increase accuracy related to subgroups that might be disparately impacted without such extra training data, even though it may not make a huge difference in overall accuracy? Like in your explorations of this, have you seen evidence for that?
Yes.
And then the second,
sorry.
Easy, next question.
Well, why don't you give me both questions, but I'll take it. Yeah.
Okay, yeah. So the second question from the same person is very astute. Like, shouldn't these sort of fairness metrics and assessments be demanded prior to deployment, not measured after the fact? So they're somewhat related questions, but like in two different directions.
So first question, just put simply, yes. These algorithms are just, they're naive when it comes to data, in the sense that they just want more of it. And the more data you give them that's more varied and heterogeneous, so it has a greater distribution in different places, usually the better they'll do. And people are intentionally creating data sets or creating methods of data augmentation that let them tweak certain things to try and improve downstream fairness metrics, which could just be as simple as having a load of pictures of people from a demographic that is not represented in your base data set, but is represented here. So that's definitely a thing people do, and it seems like a robustly useful thing. Should fairness metrics be demanded? Well, eventually, yes. But why aren't they today? They aren't today because we don't really have these metrics. If we did, they'd be in the index and we'd be tracking them year over year. And also, as I kind of alluded to, my belief, which is maybe a subjective one that not all steering committee members share, but it's what I hold, is that government should ultimately be doing large-scale assessment and measurement. And my belief is if we have those institutions, that would be an appropriate place to mandate or request certain types of fairness tests be done, because the purpose of the government is to ensure equal representation for sort of citizens in the country, and this will hopefully chain out to an incentive to work on fairness.
I mean, I tend to agree with you, although I'm somewhat biased. There's a pun not intended. There's another question about this sort of a different type of elephant in the room. And it comes from several sort of audience members, which is, what exactly do you mean when you say AI? Some people are saying, you're talking about statistical learning. Other people are saying, you're just talking about deep learning. That's not AI. And still others are saying, you're talking about machine learning, not AI. So what kinds of challenges does that represent where we might not even have quite a precise definition of the thing we're trying to measure?
Yeah, step one of any policy group I've been a part of has been trying to define AI, and every policy group I've been a part of has a different definition, which should hopefully tell us that this is itself like a really hard question. Look, put sort of simply, the index probably concentrates more on machine learning because in recent years that's where there's been a tremendous growth in activity, and within that specifically deep learning, we are seeking to incorporate more metrics around sort of non-DL and non-ML things. And in this year's report, there's a long additional sort of bit of original research in our technical performance section on reasoning and SAT solvability, which I'd encourage people to read because it gives you, and that's done by our co-chair, Ray Perot, that gives you a sense of what other parts of AI look like. I do think that this is actually useful feedback, that in the future we might want to sort of state this clearly, where because the index is interested in momentum and change, that maybe has led to more of a concentration on ML and DL because that's where the momentum and change has been recently. But we would love to find more ways to actually measure and analyze symbolic or expert systems. That's an area I personally want to find out more about. So please get in touch if you ask that question or have ways to help.
Great, thank you. And maybe moving in a different direction, you showed us super interesting actor analysis on YOLO performance. You only look once.
Yeah.
And what you showed was that it originates from the University of Washington. but then it was improved upon by Russian and Taiwanese team, and then finally it was taken to really to the next level by Baidu in China. It's really interesting to sort of know that information. It's not typical to see that in one place. But the question is, what might like a key decision maker, whether that's a policymaker or a journalist or an academic, make of that? What kind of actions do you imagine they would take based on that information?
It depends on where you're sitting, doesn't it? But I think in my experience, a thing which I subjectively have tried to sort of argue against in recent years was that for many years there was a claim that America, or sometimes the West, was just like really great at AI unambiguously, and no one else really matters. And so an interesting thing to do for actor analysis, I think, is noting who the actors are and where they're from, because it usually uncovers, as this does, a much richer story. It's not even a story about like USA versus China, which you might interpret Baidu from Washington to be. It's more a story about, oh, this software is just massively widely proliferated. It's being developed globally, and we should, when you're a policymaker, your levers are not like, I will just change how academics work, because clearly, as this graph shows, you also need to change how independent developers in Russia and China think about, Russia and Taiwan think about things, or how Chinese companies do, which tells you that your range of policy actions should probably look a little different. So that's my belief. So if we provide this, it lets decision makers take more fine-grained actions, and I think more information here is just generally helpful.
Got it. So kind of piggybacking off of that, when in the section about why Jack does it, you mentioned that you have access to cutting edge research and or researchers. So you're in the room with those people. You also have a policy bent, but it appears as though most folks with policy bent don't sort of have the same access to the research that you do. Is the report necessary and sufficient to address this challenge for those who don't sort of have access? If not, how do you recommend we get more folks with policy bents engaging deeply with AI research?
The report is meant to help. It will not ever be necessary or sufficient, partly because how people educate themselves is going to be so based on the precise company or organization you work at, or country for that matter. But it is meant to help. And these are one of the, I talk to people in DC or policy people at other companies, and I actively try and find out how the index can help them more. So that is a goal. You know, what can sort of be done to improve this? Well, I think one of the things that helped me, and I did this at OpenAI, was I was like, wow, I care a lot about policy issues. And as part of that, I care a lot about issues to do with sort of fairness and bias. And I could see that all policymakers want to understand this better. And AI labs are starting to make technologies that have salient fairness and bias traits, like, you know, a language model. What I tried to do with well, what I, and specifically my really talented colleagues at OpenAI, Sandini Agarwal, Irene Suleiman, and Gretchen Kruger, and some others, is measured our systems for aspects of bias and fairness. And I think that there's just no better way to educate yourself in this area than to work with other experts and try to measure something. And we, you know, it may be imperfect, but it's going to orient you towards that space really well. And also, if you work in a large company, merely the act of measuring something will send you on some Greek odyssey through the company bureaucracy, and you'll meet a ton of people along the way. And just if you're a policy person listening to this, nothing will make your machine learning or technical colleagues like want to work with you more than you earnestly trying to measure something. That will just make them want to collaborate with you and help you. And I think it leads to really positive effects.
That's really interesting. I've never heard you put it that way before. I mean, a more concrete kind of question from the audience is, do you think policymakers in various regions are looking for AI professionals with policy experience to help design AI, or are we just not there yet? Is it sort of the other way around?
They are. They are looking for them now, and they desperately need them. And anyone who is interested in doing more here, message me. I know a ton of people, and I'd love to put you in touch. But look, here are the sort of things that are going to get built in the next few years. What does it look like to audit a deployed machine learning system? That's actually going to be something that policymakers try to do, especially for critical things. You absolutely don't want a non-technical policymaker to design that audit layer. That would be a waste of everyone's time. You want them to work with technical or machine learning oriented people to come up with a feasible layer that actually works for the technology. That's one thing. Another thing, I am working with the OECD actually on a project to do tracking of AI and its relationship to compute. That obviously benefits from technical insights from people. I'm talking to a friend of mine to help do highly technical analysis where we analyze actual AI systems or models and their compute intensity, and then we're bringing that to the OECD. So that's us already doing what you describe of having highly technical people and throwing the information in. And I think there's actually money now. For many years, I just kind of did this in a pro bono way as I'm doing the index. But my sense now is there's more people with actual money and budgets who can hire you, which is obviously quite helpful if you want to make a career of it.
Excellent. Maybe a quick one. So some folks are speaking of a different elephant in the room. You didn't mention language models in your presentation. Does the report explore them?
Yeah, the report explores them a bit, and actually maybe Deep, you want to take this, but I'll just be really clear with people. I'm co-chair of the AI Index Steering Committee. Everyone we talked to this year said we had to write loads of stuff about GPT-3. As one of the authors of the GPT-3 paper, it seems like pretty biased of me to do much there. So we do cover it in the report. It feels really, really meaningful. I think that you may have seen there are tons of metrics now being developed, especially on fairness for evaluating language models. And my hope is in a year or two, we're going to have some graphs that let us model things over time on different model classes. So there's really ambitious stuff to be done there. But Deep, maybe you want to take 1 or 2 minutes to do this, because I think, if I recall correctly, I deferred to you to write this because you weren't an author of GPT-3, so I could ask you to write this section.
Yeah, those are both true statements. Jack Bolin told me to write the section on language models for the AI Index report. So short answer is yes, it's in there. I think the two key really interesting things that we decided to highlight in the report about language models was the really surprising emergence of zero or few shot learning or in context learning that emerges as the scale of the model increases in terms of number of model parameters. And that's just sort of a genuinely phenomenal and surprising result. And I think also we kind of anticipate moving forward that there will be benchmarks that are used to sort of directly assess this, but it's just so new. So we're sort of committed at the AI Index report to measuring progress on that regime of learning over time. And that's all I'd like to say about that before putting you back in the hot seat, Jack. So here's a question from EJ, and it's, do you think we need to move to more of an incentive policy for academics or current professors to improve diversity within their AI research labs? So there seems to be a movement within corporate structure to use incentives to hire a more diverse team. Would this be useful for academic labs as well?
I think it would be, maybe this answer will come out of left field a bit, but it's something I was thinking about. So, you know, at my new company, we're obviously thinking quite a lot about hiring, and you know, one goal is don't hire exclusively white men, somewhat unsurprisingly, and hire, you know, generally be equitable in how you're approaching hiring. Obviously, it all takes work. If you want to recruit people into either an academic context or a corporate context, and they're less represented in the sector you're working in, you have to invest a lot more effort into finding those people. And also you need to ensure that it's a good environment for them. So one observation on incentives is the more support that universities can provide in terms of helping professors to sort of broaden their network and have more conversations with perhaps affinity groups or other organizations with links to these underrepresented people, the easier it will be for them to have more of a pipeline. So it's maybe some of it's an incentive thing, but some of it is just that this costs, just in terms of time, a counterintuitively large amount. And so if we can find ways to free up resources for the time piece, I think you'll see quite a lot of movement.
Yeah, that's a challenging problem that needs to be addressed more carefully.
Mm-hmm.
So kind of a different question that's at least partially related. You showed in the data that there's a preponderance of sort of AI ethics principles,
Mm-hmm.
and AI is being mentioned sort of exponentially in an exponentially increasing manner in
Yeah.
Congress, right? What are those people saying? What do those principle statements say? Are they actionable? How do you
Mm-hmm.
measure any actual change that these
Mm-hmm.
documents or these conversations affect?
So the high point of principle formation, if I recall correctly, was 2017 or 2018. And that's because, and I think it relates to the graphs I was doing, people started looking at the trends on things like computer vision and the rate at which it was being applied. We're like, geez, we probably need some principles before we start to apply this stuff broadly. But as is kind of implied, many of these principles are like qualitative, nice statements which aren't very easy to manage towards because you don't have quantitative metrics. And as I'm sort of talking about what effect does the US Congress have, what effects do those conversations have? Well, I'm not being flippant when I say you can't manage what you can't measure. My entire experience of policy is that if you turn things into metrics, you can get policy action against them. And if there aren't metrics, it puts the government or a policymaker in a deeply awkward and challenging position where they need to make editorial judgment calls, which is usually not what they've been elected to do. And so if we want to move to real ethics, I think that we need to ground some of these principles and some of these political aspirations down into sets of metrics that we manage towards. Though these metrics will be imperfect, it'll be better than what we do now, which is mostly qualitative statements. Was that too spicy? I don't know.
I mean, I agree with you. So I'm not the right person to ask. Yeah, so I think it's like, you know, you're in your framing of the question, you sort of said metrics a few times. Can you give kind of concrete examples of metrics that directly measure the impact of AI on society, or at least try to, and where they are? And
so for NLP, actually, there's a couple of data sets that came out recently. One is called CRO-S-pairs, and the other is called StereoSet. And both of them are data sets that help you measure the extent to which a language model is outputting things that could in some sense be seen as stereotypes or caricatures. Now, is it important to work on stereotypes or caricatures specifically? I'm not sure. But is it a useful way to measure how the cultural magnification of a given model is occurring? Yes, it seems highly useful to understand if models are just saying stereotypes. In the same way that you and I have probably had the experience of talking to family members, and you always notice when they start saying some crazy stereotypes about something, it's an indication that you change your disposition around them usually. So we use this as humans. That's one example. Another example, which I really like and I talked about here, is measuring the performance of something like speech recognition on different accents is such a robustly doable idea. And it's so in the sweet spot of what you want, say, policymakers to mandate. Because if I'm a policymaker and I make, say, a 411 system for my city, I have to ensure that that can hear every one of my constituents. And so if we have metrics that let us measure that continuously, I think you get fairer products or services as a direct consequence. I wish we could do more questions. I'm sorry we didn't get through all of them.
Yeah, it's wonderful. I could do this all day. But unfortunately, we're at the top of the hour and we have to stop. So I guess, Jack, if you can imagine the adulation of like several hundred participants and thanking you for spending some time with us today and answering all the questions and giving us a lovely overview of the report and your more broader work in AI and policy. So thank you. And thank you to the audience for tuning in and for the wonderful questions. And I'm sorry if I couldn't get to yours, but.
Thanks, everyone. Please tweet at me if you have further questions. I'll try and get to it this afternoon.
Great. Thanks, Jack. See you on the other side.
All right. See you later.